Imagine this. In the darkest corners of the universe, a massive star silently growing suddenly explodes with a force that shakes the entire galaxy. The energy released in this moment outshines millions of suns and propels the building blocks of life into space. This is a hypernova, a cosmic miracle standing at the threshold of destruction and creation, death and rebirth. A single explosion can profoundly affect the chemistry of galaxies, the future of planets, and even life on Earth. If there truly is such a thing as the most powerful force in the universe, it lies in the magic of the hypernova, hidden within every end, in the new beginning that lies within. If you are ready, let's dive into the ashes of the stars together to uncover the universe's most shattering secret. 1. What is a hypernova? A hypernova is one of the most powerful and destructive explosions in the universe. It is actually a massive energy explosion that occurs at the end of a giant star's life, caused by the collapse of its core. The term hypernova is generally used to describe the death of giant stars, with masses dozens of times greater than the Sun. A hypernova creates an explosion far more powerful than a supernova and profoundly affects the energy balance of the universe. Hypernovae do not merely result in the death of a star, they also eject incredible amounts of energy, light, and matter into the intergalactic void. These explosions are so intense that they can be observed from even the farthest corners of the universe. These events, discovered by humanity with the advancement of telescope technology, represent one of the brightest and shortest-lived moments in cosmic history. Each hypernova can shine as brightly as an entire galaxy for a brief period. The occurrence of a hypernova also marks the beginning of new cycles and formations in the universe. This is because these explosions scatter heavy elements, cosmic dust, and energy into their surroundings, leading to the birth of new stars and planets. It is known that many elements essential for life in the universe are released through hypernovae. Considering all this, the hypernova phenomenon is a cosmic event that reveals the destructive and creative power of the universe. These explosions, which occur in a large part of the universe, play a critical role in the processes that form the basis of planets, stars, and even life itself. For this reason, hypernovas are not only key to astronomy, but also to the mysteries of existence. By the way, if you like my video and subscribe, that's the most effective way to support me. 2. The difference between a hypernova and a supernova. Although the terms supernova and hypernova are often confused, there are fundamental differences between them. A supernova occurs when a star with a mass 8 times that of the Sun reaches the end of its life and its core collapses. A hypernova, on the other hand, is an explosion with much higher energy and intensity that occurs when much more massive stars, at least 30 to 40 times the mass of the Sun, collapse. While supernovae play a significant role in the chemical evolution of galaxies, hypernovae effectively redraw the energy map of the universe. This is because the energy released during a hypernova can be 10 or even 100 times greater than that of a supernova. The power, impact area, and traces left by a hypernova affect much larger regions of the universe and cause long-term cosmic changes. Additionally, a typical feature of hypernova is their association with gamma-ray bursts. While such intense gamma-ray bursts are not typically observed during a supernova, the brightest and shortest-lived gamma-ray bursts in the universe are observed during a hypernova. This highlights not only the hypernova's intensity, but also its power to trigger a chain of cosmic events. In summary, a supernova is a powerful sign of death and transformation. A hypernova is the pinnacle of cosmic energy, pushing the boundaries of the universe. Both are related to stellar death, but a hypernova is one of the most energetic events in the universe, and leaves its mark on galaxies. 3. How does a hypernova form? For a hypernova to occur, a very massive star must reach the end of its life. After consuming its hydrogen, the star accumulates heavy elements in its core and eventually loses its balance. When the nuclear reactions in the core cease, the star suddenly collapses under its own weight. During this collapse, the star's outer layers are ejected at tremendous speeds, while the core mostly turns into a black hole. The most critical factor in the formation of a hypernova is the star's initial mass. Stars with masses 30 times or more than the Sun's mass completely collapse their cores while violently ejecting their outer layers into space. The amount of energy, light, and radiation released is far greater than that of a normal supernova. During a hypernova, the energy released in just a few seconds can equal the energy the Sun has emitted over billions of years. During this explosion, elements and cosmic rays scattered across the universe alter the chemistry of galaxies. Gamma-ray bursts, in particular, are considered the signature of a hypernova. After the explosion, the black hole formed at the star's core may continue to grow by devouring surrounding matter and eventually become a new cosmic center in the universe. The formation of a hypernova is not merely a destructive end, but also a harbinger of new beginnings in the universe. Through these explosions, new stars, planets, and even the building blocks of life can form in space. Thus, the hypernova is a cosmic symbol of both death and rebirth. 4. The effects of a hypernova explosion on the universe. A hypernova explosion does not only mark the death of a single star, but also triggers changes in the chemical and physical balance of an entire galaxy, or even various parts of the universe. The energy released during these massive explosions, along with cosmic rays and gamma rays, spreads millions of light years away. The elements ejected into space during the explosion lay the foundation for the formation of new stars and planets. These energy waves, which reach the farthest corners of the universe, shape the interstellar environment. They can cause gas clouds in galaxies to collapse and form new stars. Additionally, they create shock waves powerful enough to destroy nearby planetary systems. Hypernova explosions also influence the chemical composition of galaxies and the rate at which stars are born. However, the radiation and cosmic rays emitted during a hypernova have the power to cause serious damage to habitable planets like Earth. It is believed that gamma-ray bursts caused by hypernovae may have been behind past mass extinctions. In other words, hypernovae are natural phenomena that influence not only the fate of space, but also that of life itself. In short, hypernova explosions play both a destructive and creative role in the universe. Through their impact on life, stars, and galaxies, hypernova are akin to the cosmic architects of the universe. This is why they are often described as the most powerful force in the universe, embodying the fascinating dance of destruction and rebirth. 5. The amount of energy released during a hypernova. The energy released during a hypernova is so immense that it is beyond the comprehension of the human mind. This massive explosion releases the total energy that the Sun emits over billions of years into space within a few seconds or minutes. The extreme intensity of this energy is one of the main reasons why a hypernova is considered one of the most powerful cosmic events in the universe. Scientists estimate that a single hypernova explosion releases approximately 10 to the 46th power joules of energy. This is an immense force capable of shaking the intergalactic environment. The energy released by a hypernova is not only emitted as light, but also as high-energy gamma rays, cosmic rays, and radiation, spreading throughout the universe. Hypernovae, which are among the brightest and shortest-lived events in the observable universe, serve as beacons in astronomical observations. Some hypernova explosions can even be powerful enough to be seen with the naked eye from Earth for a few seconds. This energy has the capacity to affect the space-time fabric around it. The enormous energy released during a hypernova ejects the star's outer layers into intergalactic space, causing the core to collapse into a black hole. During a hypernova, a large portion of the star's mass is dispersed into space at speeds close to the speed of light. In this process, materials that are the source of heavy elements and the building blocks of life in the universe are released. The explosion changes the chemical composition of the galaxy and can cause chain reactions on other stars in space. In conclusion, the energy released during a hypernova causes profound changes not only in a star, but also in the dynamics of a galaxy and even the universe. This energy serves as one of the driving forces behind the formation of new stars, the shaping of planets, and perhaps the emergence of other forms of life. A hypernova is the most spectacular way for energy to disperse into the universe in a cosmic symphony. 6. What happens if a hypernova occurs near Earth? If a massive explosion like a hypernova occurs at a distance that could be considered close to Earth on a cosmic scale, it could have extremely destructive consequences for our planet. This is because the intense radiation, gamma rays, and cosmic rays emitted by a hypernova could damage Earth's atmosphere, putting all life at risk. A significant thinning of the ozone layer in the upper atmosphere could allow harmful solar radiation to reach the surface directly, potentially triggering mass extinctions. Even if a hypernova occurs thousands of light years away from Earth, the light and radiation waves reaching our planet can trigger chemical reactions in the atmosphere. Gamma-ray bursts are thought to have been the cause of some mass extinctions that occurred on Earth in prehistoric times. Radiation from a hypernova can affect the entire food chain, starting with plankton in the oceans, and cause long-term ecological changes on the planet. Additionally, cosmic rays released during a hypernova explosion could damage technological infrastructure and satellites in space. Such an event could negatively impact electrical grids, communication systems, and even human health on Earth. In the modern era, the effects of such a destructive cosmic event could bring global-scale disaster scenarios to the forefront. The explosion of a hypernova of such immense power near Earth would once again highlight humanity's vulnerability in the face of nature. However, it also serves as a reminder of how vast, complex, and full of unexpected events the universe is. Fortunately, no known hypernova candidate stars are currently dangerously close to Earth. 7. The relationship between hypernovae and black holes. A hypernova is a massive explosion that occurs at the end of a star's life, and a black hole is often left behind after the explosion. In fact, many black holes in the universe originate from hypernova explosions. This is because when the core of a star with sufficient mass collapses, the gravitational force becomes so intense that the core collapses inward at a certain point and transforms into a black hole. This process is one of the fundamental mechanisms behind the formation of black holes in the universe. During a hypernova, the outer layers are ejected into space, while the central core shrinks, compresses, and eventually reaches infinite density. At this point, the laws of physics as we know them no longer apply. Space and time seem to bend. The resulting black hole continues to grow by devouring the surrounding matter and becomes a new player in the galaxy's energy balance. Sometimes, black holes formed after a hypernova can transform into active galactic nuclei or quasars by devouring the surrounding matter. The relationship between hypernovae and black holes helps us understand the destructive and creative forces of the universe. As black holes absorb matter from their surroundings, they emit high-energy rays and particles into space, influencing galactic dynamics. Thus, a hypernova is not just an end, It is the beginning of a new cosmic process. The mystery of black holes remains one of the greatest unknowns in the scientific world. In conclusion, the relationship between hypernovae and black holes is one of the most powerful stories of transformation in the universe. A star dies, explodes, and then a new hungry point in space, a black hole, is born. This cycle forms one of the most important links in the chain of endless change and rebirth in the universe. 8. Hypernovae and gamma-ray bursts. Hypernova explosions are among the brightest and most energetic events in the universe. One of the most striking features of these explosions is that they often lead to very powerful gamma-ray bursts, GRBS. Gamma-ray bursts are incredibly intense and short-lived bursts of radiation that can last from a few seconds to several minutes. The high-energy jets ejected from the poles of the star during a hypernova are the source of these bursts. Gamma-ray bursts are so powerful that they can be detected from billions of light-years away. Scientists believe that a significant portion of the brightest light sources observed in the universe are actually gamma-ray bursts originating from hypernovae. During these bursts, the immense energy density is so great that it can even affect the fabric of space-time. Each gamma-ray burst also profoundly impacts the distribution of elements and cosmic dust in space. One of the most striking aspects of gamma-ray bursts originating from hypernovae is their potential to pose a threat to Earth. This is because such powerful radiation can cause chemical changes in the atmosphere, negatively impacting living organisms. In the scientific community, there is ongoing debate about whether some of the major mass extinctions on Earth may have been caused by gamma-ray bursts originating from hypernovae. This close connection between hypernovae and gamma-ray bursts is one of the cornerstones of the universe's energy cycle and its destructive creative mechanisms. Every hypernova leaves a mark in the universe, while a gamma-ray burst is recorded as one of the unforgettable moments in cosmic history. These events are cosmic signs that prompt humanity to ask its greatest questions about the universe. 9. Effects of gamma-ray bursts. Gamma-ray bursts, GRBs, are among the most destructive events in the universe and are closely related to hypernova explosions. The radiation released during these explosions spreads to the far corners of the universe and has the power to burn and destroy everything in its path. It is believed that gamma rays could thin the atmosphere and threaten life on the surface of planets, potentially leading to the complete extinction of life on some planets. The intensity of these explosions is trillions of times greater than the largest nuclear explosions on Earth. During a gamma-ray burst, an amount of energy equivalent to what the sun emits over millions of years is released into space in just a few seconds. If one of these bursts were to occur in a galactic region close to Earth, the upper layers of the atmosphere could be severely damaged. The destruction of the ozone layer could allow harmful solar radiation to reach the Earth's surface, potentially leading to mass extinctions. Scientists are discussing the possibility that such a gamma-ray burst could have been behind some of the mass extinctions that occurred on Earth in prehistoric times. Another effect of gamma-ray bursts is their critical role in the distribution of elements and cosmic dust in space. The intense energy emitted by the burst can trigger interstellar clouds and gases, leading to the formation of new stars and planets. Additionally, these bursts cause cosmic rays to spread into the intergalactic medium, playing an important role in the chemical evolution of the universe. All these effects make gamma-ray bursts unique as both destructive and creative cosmic forces. These events, which are the signature of hypernova explosions, can determine how matter and energy are distributed in the universe, how the chemistry of galaxies is shaped, and even the evolution of life. As a turning point on a cosmic scale, gamma-ray bursts bring together the dark and light sides of the universe. Nato. Elements produced after a hypernova. Hypernova explosions are not only destructive, they are also the primary source of chemical richness in the universe. Heavy elements formed in the cores of stars and scattered into space during the explosion form the building blocks of new stars, planets, and living organisms. During a hypernova, heavy elements such as iron, nickel, gold, platinum, and uranium are formed and ejected across the galaxy. It is thought that rare elements on Earth, such as gold and platinum, may have originated from massive star explosions, particularly hypernovae, that occurred in the distant past. This is because without such massive explosions, the formation of these elements would be impossible. The extreme temperatures and pressures generated during the explosion allow atoms to fuse together and form heavier elements. This makes hypernovae one of the primary architects of chemical diversity in the universe. These elements, now free in space, accumulate over time within interstellar gas and dust clouds, enabling the formation of new stars and planets. In essence, the source of the heavy elements found on Earth and within our bodies stems from hypernova explosions that occurred billions of years ago. The phrase, "we are all made of stardust," is rooted in this very reality. The richness spread throughout the universe after a hypernova ensures the continuation of the cosmic cycle. Each explosion lays the foundation for new life and makes the formation of complex molecules in the universe possible. A hypernova is not merely an end, but also an indispensable beginning of the chemical and biological evolution of the universe. 11. The birth of heavy elements. In the early universe, only light elements such as hydrogen and helium existed. The emergence of heavier elements required much more intense events with immense temperatures and pressures. Hypernova explosions filled this void, and the heavy elements formed through nuclear reactions in the stellar core were dispersed into space during the explosion. Almost all elements heavier than iron were formed through such explosions. During this process, temperatures and pressures exceeding the limits of nuclear fusion caused atoms to fuse together, forming elements such as gold, platinum, and uranium. Each hypernova explosion enriched the chemical composition of the universe, while also facilitating the spread of heavy elements between galaxies. These elements scattered into space provided the raw material for the formation of new stars and planets. Nearly all of the elements heavier than iron found on Earth today are inherited from such violent explosions. From the gold jewelry we wear to the rare metals in our computers, many things trace their origins back to a hypernova that once occurred. In other words, the true birth of many valuable materials in our lives is the product of a death that took place in the distant corners of the universe. This unique cycle makes the development of life in the universe possible. Thanks to hypernovae, the building blocks for new life and new planets are prepared both on Earth and in other corners of the universe. In cosmic terms, without hypernova explosions, the emergence of life in the universe would be nearly impossible. 12. The end of a star's life, hypernova. Just as a star's birth is critical to the universe's cycle, so is its death. Massive stars, at the end of their lives, consume the fuel in their cores, and nuclear fusion can no longer continue. As the outer layers collapse inward, the core rapidly compresses and eventually explodes. A hypernova. This explosion marks the end of the star's life with immense energy, while also triggering the beginning of new cosmic processes. The end of a star's life is actually a sign of a new beginning for the universe. This is because the elements dispersed into space during a hypernova enrich the chemical composition of the galaxy and lay the groundwork for the formation of new star systems. Additionally, this explosion releases an enormous amount of energy into space, facilitating the redistribution of matter and energy throughout the universe. After the star's death, the remaining core either becomes a black hole or a neutron star. These new formations begin to play a significant role in the gravitational balance and energy flow of the galaxy. A hypernova is not merely a death, but also signifies the birth of complex cycles, new life, and new systems within galaxies. Thus, the end of a star's life with a hypernova is one of the most striking examples of the continuous transformation in the universe. A hypernova is both an end and the starting point of an infinite cycle. 13. The relationship between star mass and hypernovae. Whether a star will explode as a hypernova is directly related to its initial mass. Stars with masses dozens of times greater than the Sun's, when they reach the end of their lives, can no longer sustain the energy produced in their cores and suddenly collapse under their own mass. This immense mass is the primary determinant of the intensity and scale of the hypernova explosion. The greater the mass, the more intense the collapse, and the more massive the explosion. While small and medium-sized stars complete their deaths as supernovae, or in a more peaceful manner, only the truly massive ones experience a hypernova-like end. This also affects the frequency of hypernovae in galaxies and their chemical richness. Massive stars are the primary factories of heavy elements in the universe, and only they can scatter these elements into space through hypernova-level destruction. An increase in mass leads to a shorter star life and a much more energetic explosion at the end. This mass catastrophe relationship plays a tremendous role in the chemical evolution of the universe. Because only the heavy elements produced by the deaths of the largest stars form the raw material for new stars and planets. Thus, a hypernova contributes not only to the size of the star, but also to the overall evolution of the universe. The largest stars are the triggers for new cycles in the universe. In conclusion, a star's initial mass determines its fate, the energy it will release into the universe, and the legacy it will leave behind. A hypernova spreads the immense energy of these massive stars into the universe as their final outburst, opening the door to endless transformation. The larger the star, the greater the impact of its explosion on the universe. 14. Hypernova observations and discoveries. Hypernova observations have been a turning point in humanity's journey to understand the universe. As modern telescope technologies have advanced, astronomers have been able to observe these extraordinary energetic explosions in distant galaxies for the first time. These explosions are often so bright that they temporarily outshine the entire galaxy. When observations suggested that hypernovae might be related to gamma-ray bursts, a new field of research emerged for astronomers. As observation techniques improved, it became possible to study the details of hypernova explosions. Thanks to spectral analysis, it is now possible to determine which elements are released into space during these explosions, how much energy is released, and what effects the explosion has on the universe. Telescopes can even observe distant hypernovae that cannot be seen in optical light, using radio, infrared, and gamma-ray wavelengths. This highlights the universal nature of hypernova science. Another important contribution of hypernova observations is that they enable us to understand the age and chemical evolution of the universe. Traces of hypernova that occurred in the distant past contain important information about how galaxies evolved into their present state. Scientists can model the processes that took place in the early universe by following these traces. Today, the direct observation of hypernova explosions and the subsequent tracking of their effects represent one of the greatest achievements of modern astronomy. Each new hypernova discovery opens the door to entirely new secrets about the workings of the universe and prompts humanity to reconsider its place in the cosmos. 15. How do scientists detect hypernovae? To detect short-lived and extraordinarily violent events like hypernovae, scientists use advanced technologies and various observation networks. In particular, space telescopes that detect gamma-ray bursts have become one of the most effective tools in the hunt for hypernovae. Operating outside Earth's atmosphere, these telescopes can record massive explosions occurring in the universe in real time. An intense gamma-ray signal from any direction could indicate a potential hypernova explosion. Observation networks, supported by optical telescopes, can track the brightness and light curve of a hypernova explosion in space. Scientists conduct spectrum analyses to determine which elements are dispersed into space following the explosion. These analyses help us decipher the chemical signature of the hypernova and provide insights into its effects on the universe. Thanks to technological advances, we are no longer limited to observations from Earth. Satellites and telescopes that detect different wavelengths are also used. This allows events like hypernovae, which are instantaneous and develop very quickly, to be observed simultaneously by many research centers around the world. This global collaboration represents one of the most impressive achievements in the field of astronomy. Hypernova detection pushes the boundaries of both technology and human curiosity. By observing such events, scientists are taking significant steps toward understanding the dynamics of the universe, the origin of elements, and cosmic evolution. Each new hypernova observation provides new clues about humanity's role in the universe. 16. Black holes formed after a hypernova. A black hole is often left behind after a hypernova explosion. And these black holes are among the most mysterious and powerful objects in the universe. The collapsing cores of massive stars become so dense and compressed during a hypernova that their gravitational pull reaches a point where even light cannot escape. The birth of a black hole is an event that tears the fabric of space-time and can alter the flow of energy in the universe. These black holes continue to grow by rapidly devouring the matter around them. Supermassive black holes, which form at the centers of galaxies, are one of the main reasons why galactic cores are so energetic. Black holes originating from hypernovae can sometimes transform into active galactic nuclei or quasars, becoming the brightest and most energetic objects in the universe. Black holes are not merely the end of a star, but the beginning of new cosmic events and interactions. The existence of black holes formed after hypernovae also has a significant impact on the distribution of matter and energy in the universe. By attracting gas and dust clouds around them with their gravitational pull, they can influence star formation in these regions. In some cases, the merger of two black holes can give rise to new and larger gravitational waves in the universe. In conclusion, the formation of black holes after hypernovae plays a central role in the universe's grand transformation story. This process, which begins with a hypernova, continues with the gravitational pull of the black hole and opens the door to new events in the universe's endless cycle. The mystery of black holes keeps humanity's curiosity about the secrets of space alive. 17. The speed of light and wave effect of a hypernova. The energy and light released during a hypernova explosion spread throughout the universe at a speed and power that is almost unimaginable. Light is the fundamental speed limit of the universe, and the flash produced by a hypernova explosion can reach millions or even billions of kilometers away in seconds. The electromagnetic waves emitted during these explosions, visible light, radio waves, X-rays, and gamma rays, travel in all directions at the speed of light. As a result, the glow of a hypernova can be briefly observed by observers in distant galaxies. The propagation of light and energy waves does more than provide a visual spectacle. It also carries information and influence to different regions of the universe. Hypernova-generated waves affect interstellar gas and dust clouds, paving the way for the birth of new stars. The energy carried by the waves alters the temperature and motion of matter in these regions. Thus, the impact of a hypernova in the universe is not limited to its own galaxy. Through waves, it initiates a cosmic chain reaction. Shock waves formed during a hypernova explosion can even penetrate the fabric of space-time. Especially powerful gamma-ray bursts are signals that can be observed from Earth and reveal to scientists what is happening in the far corners of the universe. These shock waves shape the intergalactic environment and play a significant role in the distribution of matter. Additionally, gravitational waves formed after a hypernova can create ripples in the depths of space, enabling the practical observation of Einstein's theory of general relativity. In conclusion, the light and wave effects of a hypernova are among the most striking indicators that the universe is a living, dynamic, and constantly changing structure. Every hypernova leaves its mark on the universe, not only at the moment of its explosion, but also long after it has faded. The light and energy observed provide humanity with invaluable insights into the workings of the cosmic order. 18. Hypernova and the spread of cosmic dust. A hypernova explosion ejects enormous amounts of cosmic dust and matter into the galaxy. Elements torn from the core of the star are scattered in all directions with the explosion. These cosmic dust particles disperse in the interstellar medium, providing raw material for the formation of new stars and planets. The dust and elements emitted by hypernovae play a central role in the chemical evolution of galaxies. Cosmic dust not only physically alters the chemistry of galaxies, it also absorbs and re-emits light. This creates significant effects on brightness, color, and visibility in space. Cosmic dust originating from hypernovae condenses into intergalactic gas clouds, laying the foundation for new star-forming regions. Thus, the dust and gas clouds born from a hypernova's impact sustain the universe's continuous cycle of renewal. Scientists track cosmic dust to determine where and when hypernova explosions occurred in a galaxy. Each dust particle carries traces of past massive explosions, stellar deaths, and universal transformations. These dust particles also contribute to the chemical richness of our planet by reaching Earth. The spread of cosmic dust can be seen as one of the building blocks of life in the universe. This is because the formation of new star and planetary systems depends on the presence of this dust and its elements. Although a hypernova is a moment of destruction, the cosmic dust it scatters into the universe opens the door to new life and new formations. 19. New stars born after a hypernova. The gas and dust clouds scattered into space following a hypernova explosion eventually condense again, leading to the birth of new stars. This process is one of the most fundamental mechanisms of star formation in the universe. In other words, the death of a star triggers the birth of others. The heavy elements and cosmic dust dispersed into space during the explosion accumulate in interstellar clouds, triggering collapse and the formation of new star clusters. The formation of new stars not only increases chemical diversity, but also alters the dynamic structure of the galaxy. Each hypernova creates suitable conditions for new stars in different regions of the galaxy. This cycle enhances the potential for life in the universe, because around newly formed stars, planets and systems capable of harboring life may emerge. The new wave of births following a hypernova increases the chemical richness of the galaxy. As a result, elements and compounds that were previously non-existent become the building blocks of new star systems. The source of diversity and complexity in the universe lies in this chain of cyclical explosions and births. In short, a hypernova explosion is not merely an end, but also the beginning of a universal rebirth. This process, which begins with the death of a star, holds the key to the endless renewal of galaxies and the cosmic continuation of life. Every hypernova lays the foundation for a new universe. 20. The effect of hypernovae on galaxies. The effect of hypernova explosions on galaxies is not limited to local changes. A hypernova in a galaxy causes a major disturbance in the surrounding star systems and accelerates the chemical evolution of the galaxy. The enormous energy released during the explosion can trigger gas clouds in different regions of the galaxy, leading to new star formation. This directly affects the overall dynamics of the galaxy and the star formation rate. Areas in galaxies with high hypernova explosion rates are generally the richest in chemical diversity. This is because the heavy elements scattered during the explosion contribute to the formation of new star systems and planets. The chemical map of a galaxy is shaped by the traces of these massive explosions. While a hypernova can temporarily disrupt a galaxy's energy balance, it ultimately enhances its chemical and structural richness in the long term. In some cases, if a hypernova explosion occurs near the galactic core, it can trigger the feeding of black holes and active galactic core processes. This leads to massive energy releases and radiation bursts at the center of the galaxy. In other words, a hypernova is a cosmic catalyst that affects not only stars, but the entire galaxy. In summary, hypernova explosions play a central role in the evolution of galaxies. Chemical diversity, the formation of new stars and planets, energy distribution, and galactic dynamics are shaped by these explosions. Hypernovae are among the most powerful cosmic events that enable the rebirth of galaxies and the continuous increase of diversity in the universe. 21. Hypernovae and the evolution of the universe. Hypernova explosions play a critical role in the large-scale evolution of the universe. Each hypernova increases chemical richness in galaxies and the interstellar medium, enabling new life cycles to begin in the universe. In the early stages of the universe, when only light elements, hydrogen and helium, existed, heavy elements began to form through violent explosions like hypernovae. These heavy elements became the fundamental building blocks for galaxies, stars, and planets. In other words, without hypernova explosions, the universe would not possess the diversity and structural richness we know today. Massive explosions like hypernovae also accelerate the circulation of matter and energy in the universe. This leads to the emergence of new stars and planets in different regions of galaxies. The elements and cosmic dust dispersed by hypernovae freely circulate in the intergalactic medium, triggering new chemical and physical processes across the entire universe. In the ever-expanding and evolving structure of the universe, events such as hypernovae are the key to renewal and development. When we examine the evolution of the universe over time, we encounter both the chemical and dynamic effects of hypernova explosions. The chemical evolution of galaxies has been shaped by the traces of these massive explosions, laying the foundations for life in the universe. In other words, the history of the universe is actually an accumulative process created by countless hypernova explosions. Each new explosion contributes to the future of the universe in a small but significant way. In conclusion, hypernova explosions play an indispensable role in the evolution of the universe. These events, which are both destructive and creative in a cosmic sense, are the source of the universe's fundamental chemical building blocks and energy. Hypernovas symbolize the continuity and change of the universe. Every star that disappears paves the way for new beginnings. 22. Radiation emitted by a hypernova explosion. The radiation emitted during hypernova explosions is one of the most powerful energy releases in the universe. The main components of this radiation are gamma rays, X-rays, visible light, and radio waves. Gamma ray bursts, in particular, are frequently associated with hypernovae and create a short-lived but extremely intense energy outburst in space. The radiation emitted during a hypernova explosion can reach the farthest corners of a galaxy and even be observed from other galaxies. The emitted radiation affects the surrounding interstellar medium, triggering new chemical reactions. Radiation from hypernovae can ionize gas clouds in galaxies, triggering the conditions necessary for the formation of new stars. However, this intense radiation also has the potential to damage the atmosphere of habitable planets like Earth. Historically, it has been suggested that such powerful cosmic radiation could have played a role in some mass extinctions. Scientists analyze the spectral properties of radiation emitted during a hypernova to determine the chemical composition and energy of the explosion. This provides detailed information about how much energy the hypernova released, which elements were formed, and the effects of the explosion on the universe. The journey of the emitted radiation through space also offers important clues for understanding cosmic time and distance. The spread of radiation ensures that a hypernova leaves lasting effects not only on the region where it occurs, but on the entire universe. This radiation is like the last words of a hypernova, echoing through the universe, and carries great secrets about the workings of the universe from both a scientific and philosophical perspective. 23. The danger of hypernovae to life on Earth. Hypernova explosions are generally harmless when they occur at great distances from Earth. However, if a hypernova occurs in our galaxy or nearby, it could pose a significant threat to life on Earth. The greatest risk comes from the intense gamma rays and other high-energy radiation emitted during the explosion. This radiation can damage the ozone layer in the upper atmosphere, allowing harmful ultraviolet rays to reach the Earth's surface. In such a scenario, mass extinctions could occur in both terrestrial and marine ecosystems. In history, there are theories suggesting that some disasters leading to mass extinctions may be linked to cosmic radiation or gamma-ray bursts from space. For example, during the Ordovician-Silurian extinction approximately 440 million years ago, the destruction of the ozone layer in the atmosphere led to the extinction of most living species. Some scientists believe this catastrophe may have been related to a gamma-ray burst caused by a hypernova. Another danger of hypernova explosions to life is the entry of high-energy particles into the atmosphere, which can cause biological mutations. In such a scenario, genetic changes and permanent damage to living species could occur. Additionally, the cosmic dust clouds formed after the explosion could block sunlight, leading to global climate changes. While there is currently no such threat in our vicinity, it should not be forgotten that such events can occur in the universe, albeit rarely. Hypernovae serve as a striking reminder of the fragility of life and the vast scale of the cosmic order, both through their destructive potential and their universal regenerative power. 24. The relationship between hypernova and mass extinctions on Earth. Looking back at Earth's history, we see several major mass extinctions, and some scientists suggest that these may have been caused by extremely violent cosmic events originating in space. Gamma-ray bursts from hypernovae are among the strongest candidates for these catastrophes. This is because the intense radiation emitted during these explosions can destroy the ozone layer, thereby threatening life on Earth in an instant. Scientific research has shown that during certain periods, such as the Ordovician-Silurian extinction, sudden and global climate changes, excessive thinning of the ozone layer, and mass deaths of living species occurred. It is suggested that gamma rays from hypernova explosions ionize molecules in the atmosphere, leading to the thinning of the ozone layer. As a result, the sun's harmful rays can reach the Earth's surface directly, causing mass deaths from the lowest to the highest levels of the food chain. The connection between hypernova explosions and mass extinctions leads not only to changes in the biosphere, but also to changes in the planet's overall chemistry. The cosmic dust and gas clouds that follow the explosion can cause a decrease in sunlight in Earth's atmosphere, leading to global cooling and the collapse of ecosystems. Such catastrophes could facilitate the reshaping of life on Earth and accelerate evolutionary processes. In conclusion, hypernova explosions may have played a role in major turning points in the history of life on Earth. These events highlight both the fragility of our planet and the vastness of the universe. Life is as much a product of a fortunate cosmic coincidence as it is open to change at any moment in the shadow of a destructive stellar explosion. 25. The effect of hypernovae on cosmic background radiation. Cosmic background radiation is a very weak microwave radiation from all directions, dating back to the early universe and carrying traces of the universe's birth. Massive explosions, such as hypernovae, can cause tiny but detectable fluctuations in this background radiation. The intense energy and high-energy particles released during the explosion can locally alter the structure of the background radiation and create minor temperature differences across vast regions of the universe. These differences are small enough to be detected only through precise measurements, but hold important clues for understanding the history of the universe. Hypernova explosions, especially if they occurred more frequently in the early universe, may have caused certain anomalies in the distribution of cosmic background radiation. Scientists suggest that these massive stellar explosions may have left traces that explain some unexpected deviations in the background radiation. In other words, each hypernova is a small but meaningful brushstroke in the big picture of the universe. Today, detailed mapping of cosmic background radiation is helping astrophysicists understand the role events like hypernovae play in the evolution of the universe. These maps contain countless pieces of information about the universe's expansion, structural formations, and chemical evolution. The small temperature fluctuations created by hypernovae make it possible to trace the traces of large cosmic processes. As a result, the effect of hypernova explosions on cosmic background radiation provides scientists with invaluable data about the universe's past. The universe's memory is filled with the traces left by such massive explosions, and each new observation sheds more light on the cosmic past. 26. Hypernovae and the formation of interstellar molecules. Hypernova explosions not only produce heavy elements, but also trigger the formation of complex molecules in the universe. The energy released during the explosion initiates new chemical reactions within gas and dust clouds. Elements essential for life, such as carbon, oxygen, and nitrogen, are abundant in the interstellar medium following these violent explosions and transform into various molecules. The formation of interstellar molecules enables the emergence of new star systems and potentially habitable planets within galaxies. The energy released during a hypernova heats and ionizes interstellar clouds, allowing even complex organic molecules to be synthesized. This process is the key to the chemical diversity and complexity of the universe. In particular, the detection of amino acids and other organic building blocks in interstellar clouds is an indicator of molecular richness originating from hypernovae. Scientists are tracking the traces of newly formed molecules through observations of hypernova remnants and the surrounding interstellar environment. Each hypernova transforms the chemistry of the galaxy while distributing the materials necessary for the evolution of life into the cosmos. Thus, the death of a star creates the molecular richness that will open the door to new life in the universe. The formation of these molecules plays a fundamental role in the evolution of galaxies and the cosmic journey of life. Without hypernova explosions, such complex and rich chemical processes would not be possible in the universe. Each explosion acts as a kind of universal laboratory, preparing the universe for the birth of new life. 27. The difference between the energy of a hypernova and other explosions. Among the explosions witnessed in the universe, hypernovas are by far the most energetic. While even a supernova pales in comparison, the energy released during a hypernova explosion can be equivalent to the light emitted by an entire galaxy in a year. This extraordinary amount of energy is not only light, but also gamma rays, X-rays, and cosmic rays that are scattered throughout the universe. To understand the magnitude of a hypernova's energy, the following comparison can be made. While a typical supernova releases approximately 10 to the 44th joules of energy, a hypernova can reach levels of 10 to the 46th joules. This represents a magnitude of power that is beyond human comprehension. The energy density is so intense that it can affect the intergalactic void during the explosion and leave permanent traces in the surrounding cosmic structures. The hypernova's unique power makes it the greatest catalyst for cosmic cycles in the universe. It plays a central role not only in terms of chemical richness, but also in the emergence of new structures and energy flows in space. The intensity and duration of gamma-ray bursts are also clear indicators of the hypernova's unique power. Ultimately, a hypernova explosion stands out as the energy king among all known explosions in the universe. This immense power triggers profound changes in the ever-evolving structure of the universe and plays a decisive role in the cosmic evolution. 28. Chemical changes in the universe after a hypernova. A hypernova explosion leaves deep marks on the chemical map of the galaxy. The heavy elements produced during the explosion spread throughout the galaxy, triggering new chemical processes. Rare and heavy elements such as iron, nickel, gold, and platinum mix into the interstellar medium through hypernovae. Thus, the chemical richness and diversity of the universe increases slightly with each explosion. Chemical changes are not limited to the spread of heavy elements. The energy released by hypernovae also enables the synthesis of new molecules and the emergence of complex organic structures in interstellar clouds. This makes it possible for new stars and planets to have different chemical compositions. Each hypernova is considered a chemical milestone in the evolution of the galaxy. The changes initiated by hypernovae directly influence star formation and planetary diversity in galaxies. As a result, the likelihood of life emerging increases exponentially. Chemical diversity and molecular richness are the building blocks of cosmic evolution, and hypernovae are their source. In the long term, the chemical changes following a hypernova determine the age, structure, and potential for life within a galaxy. The chemical legacy of these massive explosions lies at the heart of the universe's vitality and regenerative capacity. Every new hypernova leaves an indelible mark on the chemical map of the universe. 29. The effect of a hypernova on the fabric of space-time. Hypernova explosions affect not only matter and energy, but also the fabric of space-time, the fundamental structure of the universe. As a star's massive core collapses into a black hole during a hypernova, it warps and distorts the surrounding space-time. These ripples propagate through the universe as gravitational waves, as predicted by Einstein's theory of general relativity. The waves created by a hypernova are like temporary wrinkles in space itself and spread outward at the speed of light. The discovery of gravitational waves has enabled us to observe the direct effects of large-scale explosions like hypernovae on the deep structure of the universe. Scientists are tracking the traces of major events in the universe by detecting these waves with special detectors. Hypernova origin waves are not only related to stellar death, but may also be connected to larger cosmic events, such as galaxy mergers or black hole collisions. This bending of the space-time fabric could influence intergalactic matter flow and the overall structure of the cosmic order. The traces left by hypernovae can sometimes create small but measurable changes in the structure of a galaxy or nearby star systems. This temporary fluctuation in space-time once again reveals the dynamic and variable nature of the cosmic order. The waves created in the fabric of space-time by a hypernova explosion are revolutionary, not only for astrophysical observations, but also for understanding the fundamental laws of the universe. The existence of gravitational waves shows that the universe is a constantly moving, vibrating whole that is reshaped by every major event. Each hypernova is a brief but impressive figure in this universal dance. 30. Scientific study of hypernovae. The scientific study of hypernova explosions is one of the most exciting and challenging areas of modern astronomy. The instantaneous and short-lived nature of these massive explosions has driven scientists to develop observation networks capable of responding instantly and high-precision telescopes. In particular, gamma-ray telescopes in space and wide-angle observation satellites have become indispensable tools for detecting and analyzing hypernova explosions. Spectral analyses of the light, radiation, and gravitational waves emitted during the explosion provide valuable insights into the hypernova's chemical composition, energy levels, and the traces it leaves in the universe. Scientists combine the data obtained during observations with computer simulations to create detailed models of the hypernova. These models enable us to understand how the explosion began, how it spread, and what kinds of changes it caused in its surroundings. Scientific studies have made significant progress not only in the observational field, but also in the theoretical realm. New physical theories explaining hypernova processes provide answers to important questions about the large-scale evolution of the universe and the life cycle of stars. These studies push the boundaries of human knowledge in both cosmology and fundamental physics. Each new hypernova observation provides a deeper and more detailed view of the universe. Thanks to these studies, which are the driving force behind scientific progress, we are getting closer to the secrets of the universe every day. Hypernova research is like a powerful projector that illuminates the cosmic unknown. 31. Hypernovae and the spread of new elements in space. During a hypernova explosion, matter ejected from the core into space causes the emergence of new elements that did not previously exist in the universe. Under immense heat and pressure, the nuclear fusion chain in the star's core is triggered one last time, resulting in the formation of elements heavier than iron. These elements are dispersed throughout the galaxy by the hypernova explosion. Thus, new colors are added to the ever-expanding palette of cosmic chemistry. These newly formed elements accumulate in interstellar dust clouds and eventually form the building blocks of new stars, planets, and even living organisms. The origin of elements like gold, platinum, and uranium, which are rare on Earth, traces back to these massive explosions. Without hypernova explosions, the natural formation of these heavy elements in the universe would not be possible. The new elements spreading throughout space accelerate the chemical evolution of the galaxy and increase cosmic diversity. Each new hypernova enriches the universe's raw material reserves and adds a fresh breath to the cosmic cycle. Scientists can determine the origin of these elements by analyzing the isotope ratios of elements found in the interstellar medium. Ultimately, thanks to hypernovae, chemical richness in the universe continuously increases, and all the building blocks necessary for the emergence of new life forms are dispersed throughout the universe. Hypernovae are both the scholar and the gardener of the universe. They destroy, transform, and enable new life to sprout. 32. The expansion of the universe associated with hypernovae. The expansion of the universe refers to the continuous movement of the entire cosmic structure in a pattern of increasing distance, and hypernova explosions play both a signaling and triggering role in this process. The immense energy released during hypernova explosions accelerates matter within galaxies and can push some interstellar clouds out of the galaxy. This process contributes to the formation of the halo and expansion regions around galaxies. The energy released during the explosion accelerates matter flow on a cosmic scale and can directly or indirectly support the expansion of the universe. In particular, gas and dust ejected into the intergalactic void can trigger the formation of new galaxies or alter the density of matter around existing galaxies. In some regions, the hypernova's effect may reduce matter density, while in others, new cosmic structures may emerge. Hypernova explosions provide scientists with unique cosmic markers for studying the expansion of the universe. Observing these explosions is used to measure the movements of distant galaxies and the rate of the universe's expansion. This allows for a more detailed mapping of the large-scale structure of cosmic evolution. Ultimately, the connection between hypernovae and the expansion of the universe helps us understand the past of the universe and make predictions about its future. Hypernovae are not just the end of a star, but also an active part of cosmic expansion. 33. The relationship between hypernovae and quasars. There is a striking connection between hypernova explosions and quasars. Quasars are celestial objects that orbit around supermassive black holes located at the centers of galaxies, emitting extreme brightness and intense radiation. The hypernova explosion of a massive star and the subsequent formation of a supermassive black hole can contribute to the formation of quasars in the centers of galaxies over the long term. The massive black hole formed after a hypernova can swallow the matter around it and emit enormous bursts of energy and radiation with its rotational energy. The gas and dust clouds emitted by hypernova explosions also play an important role in the feeding process of quasars. This matter, which is drawn toward the galactic center, accumulates in the accretion disk around the massive black hole, becoming the source of the quasar's immense brightness. The energy released by the hypernova accelerates the flow of matter around the quasar, enabling the black hole to grow faster and emit more intense energy. This process shapes the energy and matter cycle at the centers of galaxies. Observations have shown that the regions where the brightest quasars are found are areas that have experienced numerous hypernovae and similar massive explosions in the past. Each new hypernova directly affects the brightness and activity of the quasar by transporting new matter and energy to the galactic center. Therefore, hypernovae are one of the key components of quasar formation and galactic energy balances. Understanding the relationship between hypernovae and quasars opens the door to unraveling the most intense and energetic processes in the universe. These two massive cosmic events symbolize the great transformations in the universe and the flow of energy between galaxies. A hypernova is not just the end of a star, but also triggers the birth of new energy centers at the heart of a galaxy. 34. Remnants of a hypernova. When a hypernova explosion ends, extraordinary traces remain in space. These remnants are scattered throughout space in the form of a super-dense black hole, a vast cloud of gas and dust, ionized heavy elements, and electromagnetic waves. The material left over from the explosion directly contributes to the chemical richness of the galaxy. Additionally, through observable remnants, astronomers can analyze the hypernova's energy, explosion type, and the elements it dispersed into the environment. The gas and dust clouds that emerge after a hypernova serve as the foundation for the formation of new star clusters and planetary systems in the interstellar medium. These remnants can transform into nebulae, which are the birthplaces of stars. The heavy elements scattered into space by the hypernova's energy enable an increase in chemical diversity within the galaxy. Each hypernova remnant is like a cosmic fossil from the universe's past, carrying the traces of evolutionary cycles. A black hole or neutron star remains at the center of the hypernova and continues to attract matter around it. This gravitational pull affects the dynamics of the galaxy in that region. Black holes that accumulate over time, especially in the centers of galaxies, can shape the galaxy's structure in the long term. The remnants left by the hypernova become part of the universe's large-scale architecture. These observable remnants are studied in detail using modern telescopes as well as radio and X-ray observations. The traces left behind after a hypernova are living evidence of stellar deaths, element formation, and new cosmic processes. Each remnant forms a line in the written history of galaxies and the universe. 35. Misconceptions about hypernovae. Hypernovae are cosmic events that are often misunderstood and the subject of myths in popular culture and general science communication. One of the most common misconceptions is that every large star explosion is a hypernova. In reality, only the deaths of very massive stars result in hypernovae. Smaller stars complete their life cycles through supernovae or fainter explosions. There are significant differences between hypernovae and supernovae in terms of intensity, energy output, and explosion type. Another misconception is the belief that a hypernova can instantly destroy planets, or that an explosion near Earth could instantly end life. However, there are no hypernova candidates in our galaxy that are close enough or pose such a risk. The vast majority of hypernova explosions occur thousands, even millions of light years away from Earth, and their effects are destructive only in their immediate vicinity. Gamma-ray bursts, on the other hand, can pose a threat if they occur at the right angle and are close enough. Additionally, in some science fiction works, hypernovae are depicted as a cosmic catastrophe that destroys everything. In reality, however, hypernovae are as creative as they are destructive. They are the source of heavy elements and new stars in the universe. These cyclical explosions form the building blocks of life and chemical richness in the universe. Hypernovae are not absolute catastrophes, but rather a means of infinite renewal. Correcting these misconceptions about hypernovae is important for understanding the complex nature of astronomy and the cyclical workings of the universe. Thanks to the observations and research conducted by scientists, the true role of hypernovae and their place in the universe are becoming clearer every day. By the way, liking my video and subscribing is the most effective way to support me. 36. Hypernovae and science fiction. Hypernovae have become a phenomenon frequently used in science fiction works as a symbol of both destruction and cosmic miracles. In novels, movies, and TV series, hypernova explosions are often depicted as events that destroy galaxies, threaten civilizations, or cause major disruptions in time and space. These dramatic narratives are used to capture the audience's attention and show humanity's helplessness in the face of the vastness of the universe. Many science fiction stories are based on themes such as new universes being born or completely different life forms emerging in space after a hypernova explosion. Authors push the boundaries of imagination with black holes, quasars, and exotic elements that emerge after hypernovas. While these narratives are often inspired by real scientific discoveries, they are frequently enhanced with exaggerated or metaphorical descriptions. Science fiction uses the concept of hypernova to pose profound philosophical questions about humanity's cosmic destiny, the fragility of life, and the infinite possibilities of the universe. Hypernova is not merely a catastrophe. It is also a symbol of rebirth, cosmic cycles, and universal change. In such works, the hypernova is portrayed not as an end, but as a harbinger of a new beginning. This creative relationship between real science and science fiction reminds society of the vastness of the universe, the grandeur of cosmic events, and the power of human imagination. When viewed through the cosmic lens of science fiction, hypernova is both a warning and a source of hope. The interaction between science fiction and real astronomy continues to fuel humanity's curiosity and desire for discovery. 37. Observation of hypernovae with telescopes. The observation of massive explosions such as hypernovae has become possible with the development of modern astronomy. Thanks to the continuous advancement of telescope technology, we can now detect hypernova explosions occurring in very distant galaxies. Optical telescopes, radio telescopes, and space-based X-ray and gamma-ray observation satellites have become indispensable tools in the discovery of hypernovae. These telescopes can easily distinguish the sudden flash and light curve created by a hypernova in the depths of space. Hypernova explosions are often much brighter than other stars, so they appear as temporary new stars in the sky. Scientists record and analyze these temporary flashes as light curves. Wide-field survey telescopes in particular continuously scan the sky and can immediately detect new explosion events. Some hypernovae are so bright that they can even outshine an entire galaxy for a short time. Thanks to observation technologies, it is possible to directly detect the spectrum of a hypernova at the moment of explosion, the chemical signature of the gas and dust clouds it emits, and the black hole or neutron star formed after the explosion. Observations using radio waves and infrared light can reveal remnants hidden among dust and gas clouds. Each new hypernova observation provides valuable data to the scientific community about the chemical and physical evolution of the universe. Observing a hypernova with telescopes is not merely a record of a fleeting event, but also a means of tracking the long-term transformation of the universe. Today, observatories and space telescopes around the world are collaborating in the hunt for hypernovae, enabling humanity to gain a deeper understanding of its cosmic past and future. Each observation sheds a little more light on the universe's mysteries. 38. Hypernovae and future dangers. When hypernova explosions occur in distant galaxies, they offer us nothing but scientific data and awe. However, if such an explosion were to occur in our galaxy or near a nearby star, it could pose a serious threat to Earth. In particular, the intense gamma rays emitted during the explosion could damage our planet's atmosphere, thin the ozone layer, and threaten life. For this reason, astronomers closely monitor potential hypernova candidates in our galaxy and conduct risk analyses. In the future, a massive star preparing for a hypernova explosion could spell potential disaster for Earth. Gamma-ray jets emitted from a hypernova explosion could cause mass extinctions and climate change if they were directed toward our planet. However, at present, there are no known hypernova candidates in the Milky Way that are dangerously close to Earth. But this does not mean it will never happen in the future. Scientists calculate the ages, masses, and proximity to explosion of massive stars in our galaxy to understand the future threat of hypernovae. This allows them to identify potential risks in advance and develop measures to warn Earth. With the advancement of space observation networks, hypernova explosions can be detected earlier, and more detailed information about potential threats can be obtained. Future threats serve as an important warning about humanity's place in the universe and its cosmic fragility. Hypernovae, with both their destructive potential and creative power, will always keep humanity's awareness of universal risks and cosmic consciousness alive. 39. The contribution of hypernovae to the science of astronomy. Hypernovae have been a cornerstone in the development of astronomy. Observing these extraordinary events provides invaluable data to scientists seeking answers to fundamental questions about the structure of the universe. the life cycle of stars, the origin of chemical elements, and how cosmic evolution works. Thanks to hypernovae, it has been understood that stars play a creative and transformative role in the universe, not only during their lives, but also during their deaths. Hypernova data obtained with modern telescopes and observation networks play a critical role in the study of energy transformations, matter distribution, and the emergence of new elements on a cosmic scale. Additionally, the direct observation of phenomena associated with hypernovae, such as gamma-ray bursts and gravitational waves, has sparked scientific revolutions across various fields, from Einstein's theories to modern astrophysical models. Every hypernova observation reveals how matter and energy move in the universe and how new stars and galaxies form. Hypernova studies are also of vital importance in astrobiology and the spread of life in the universe. This is because hypernova explosions are the source of heavy elements necessary for life. Hypernova research provides new insights into the abundance of elements in the universe, the origin of interstellar molecules, and the chemical evolution of galaxies. In conclusion, hypernovae have opened new horizons in both the observational and theoretical fields of astronomy. These explosions are one of humanity's most powerful tools for understanding the mysteries of the universe. Hypernovae are unforgettable heroes in the grand narrative of astronomical science. 40. Hypernovae and theories about the end of the universe. Theories about the end of the universe also take into account the role of massive cosmic explosions, such as hypernovae. While hypernovae shape the end of stars and the chemical evolution of galaxies, some theories suggest that they may also trigger much larger-scale cosmic processes. Some scientists suggest that hypernova explosions could contribute to the rapid growth of massive black holes at the centers of galaxies, potentially triggering the death of galaxies in the long term. These black holes at the centers of galaxies could disrupt the structure of the galaxy as their matter-swallowing rates increase. Different scenarios for the ultimate end of the universe include the chain reactions of events, such as hypernovae. Theories predicting the end of the universe, such as the Big Crunch, Big Rip, and heat death, suggest that high-energy explosions like hypernovae could accelerate the distribution of matter and energy between galaxies, contributing to these processes. In particular, the merger of black holes and their rapid growth at the center of galaxies can alter the overall energy and matter balance of the universe. According to some theories, the merger of black holes formed after a hypernova could trigger a new energy wave or gravitational collapse in the universe. The energy density and chemical diversity of the universe are constantly reshaped by hypernova explosions. Thus, hypernovas play both a catalytic and pivotal role in the grand cosmic scenario that is preparing for the ultimate end of the universe. Ultimately, hypernovas occupy an important place in theoretical discussions about the end of the universe. These massive explosions are cosmic events that shape not only the fate of a star or a galaxy, but also the long-term evolution and future of the entire cosmos. 41. Hypernovae and the rebirth of life. Every hypernova explosion means the death of a star with tremendous energy, but it is also the beginning of new life cycles in the universe. The heavy elements scattered into space during the explosion serve as the source of essential chemical building blocks for life, such as carbon, oxygen, and iron. These elements accumulate in interstellar dust clouds and eventually lay the groundwork for the formation of new star systems and planets. Thus, a hypernova is a cosmic moment of birth that enables new life to emerge in the universe. Following the explosion, the chemical richness of the galaxy increases, and the formation of new molecules in the interstellar medium accelerates. These new molecules provide potential raw materials for carbon compounds and amino acids, which are the building blocks of organic structures. Scientists believe that ancient hypernova explosions played a role in the emergence of Earth-like habitable planets and even life itself. On a cosmic scale, the death of a star is actually an opportunity for life to begin anew. The energy released after a hypernova not only increases chemical richness, but also triggers the collapse of interstellar clouds and the birth of new star clusters. This cycle ensures the continuous renewal of galaxies and even the entire universe. Every newly formed star and planetary system carries the chemical legacy of a past hypernova, and this legacy carries the potential for life forward with each cycle. In conclusion, a hypernova explosion is not only a symbol of destruction and death, but also of universal rebirth. The continuity of life in the universe is made possible by the rich chemical and physical environment left behind after these massive explosions. Every hypernova is a magnificent beginning that opens the door to new life in the universe. 42. Hypernovae and energy distribution in the universe. Hypernova explosions play a tremendous role in the distribution of energy in the universe. The light, radiation, cosmic rays, and gravitational waves produced during these massive events spread to every corner of the galaxy and even into the intergalactic void. This energy heats and ionizes the interstellar medium, triggering new chemical processes. The energy emitted by a hypernova is not limited to its immediate surroundings. It fundamentally alters the distribution of matter and energy on a cosmic scale. The energy released during the explosion can accelerate the collapse of interstellar clouds, initiating the formation of new stars. Additionally, gravitational waves generated by hypernovae leave lasting effects on the fabric of space. Gamma-ray bursts and cosmic rays reach as far as the intergalactic medium, reshaping the overall energy map of the universe. Such energetic events are part of the dynamic, ever-changing structure of the universe. These major changes in energy distribution also affect the chemical composition of galaxies and star formation rates. The energy released into space after a hypernova triggers new chemical reactions in the surrounding gas and dust clouds. This, in turn, facilitates new formations in galaxies and increases diversity in the universe. In conclusion, hypernova explosions play a decisive role in the energy balance and distribution of the universe. Without these massive events, the chemical richness and cosmic diversity in galaxies would not be as intense as they are today. Hypernovas are one of the most striking and powerful links in the endless cycle of energy in the universe. 43. Hypernovas and cosmic evolution. Cosmic evolution encompasses all the physical, chemical, and biological changes the universe has undergone from its earliest moments to the present day. Hypernova explosions are one of the main actors in this grand evolutionary chain. Because hypernovae shape not only the chemical and physical evolution of stars, but also that of galaxies and the entire universe. Through these explosions, new elements are formed, new stars and planets are born in galaxies, and even the fundamental building blocks necessary for life emerge. Each hypernova opens a new chapter in the evolution of a galaxy. The heavy elements and molecules left behind after the explosion serve as the primary material for the formation of new star systems and planets. This fresh start in chemical evolution directly influences the future chemical composition of the galaxy. Additionally, the energy and radiation emitted after a hypernova trigger new chemical reactions in different regions of the galaxy. The contribution of hypernovae to cosmic evolution is not only chemical, but also dynamic and physical. Gravitational waves, gamma-ray bursts, and cosmic rays trigger the flow of energy and matter within and between galaxies. Thus, the ever-renewing, changing, and complex structure of the universe is sustained. In summary, hypernova explosions are one of the most powerful links in the chain of cosmic evolution. Behind every new formation, chemical richness, and potential for life in the universe lies the trace of a hypernova that occurred in the past. The hypernova is the key to the universe's endless transformation. 44. Hypernova and the gates of infinity. A hypernova explosion is like one of the doors to infinity for the human mind. This immense event, which occurs at the end of a star's life, represents the beginning of new cycles, new elements, and even new life in the universe. The black holes left behind by hypernovas are symbols of infinity and the unknown in the depths of space. They possess the power to open the door to a new universe beyond time, matter, and energy. The doors to infinity are opened not only physically, but also philosophically and scientifically by the hypernova. Because these massive explosions are events that challenge the fundamental laws and workings of the universe, pushing the boundaries of time and space. Thanks to hypernovae, humanity rediscovers how vast, dynamic, and full of surprises the universe is. Each explosion heralds infinite possibilities, new beginnings, and cosmic cycles. The black holes and intergalactic matter flows formed in the universe after a hypernova symbolize the new structures and energies embarking on a journey into the infinity of the universe. By studying hypernova remnants and black holes, scientists ask new questions about the farthest reaches and unknowns of the universe. These events, which open the doors to infinity, show that nothing in the universe is static and that everything is constantly renewing itself. Ultimately, a hypernova explosion is both an end and a step toward infinity, an indispensable stop in the universe's great story of transformation. Every hypernova presents the human mind with endless possibilities and unexplored universes, opening new doors on our cosmic journey. 45. Hypernovae and intergalactic matter flow. Hypernova explosions not only affect the galaxy they occur in, but also serve as one of the primary drivers of intergalactic matter exchange. The high-speed gases, dust, and heavy elements ejected during the explosion cross the galaxy's gravitational boundary and spread into intergalactic space. This process can be thought of as cosmic migration, as the material dispersed by hypernovae reaches other galaxies, enhancing the overall chemical richness of the universe. Frequent hypernova explosions during the early universe were one of the most significant factors shaping the diversity and chemical composition of today's galaxy clusters. This intergalactic flow of matter plays a critical role in the formation of new star and planetary systems. Each explosion provides nearby galaxies with heavy elements and dust, altering the chemical composition of the interstellar clouds there. This interaction ensures that the intergalactic medium remains an active component of the universe and contributes to the continuity of the energy-matter cycle in the cosmos. A hypernova transforms the intergalactic void into a bridge to new possibilities for life and chemistry. When scientists investigate the origin of certain heavy elements and isotopes detected in the intergalactic medium, they find that most of them can be explained by hypernova explosions. These observations demonstrate that hypernovae play a significant role not only within a single galaxy, but also between galaxies. Intergalactic chemical interaction is one of the primary reasons behind the richness and diversity of the universe today. In conclusion, hypernova explosions are one of the main drivers of matter flow and chemical evolution between galaxies. Each new explosion carries the building blocks of life and new chapters of the cosmic story to every corner of the universe. The hypernova is a great cosmic messenger connecting even the farthest corners of the universe. 46. Hypernova and the flow of time. Hypernova explosions not only play with matter and energy in the universe, but also with our perception of time. The intense gravitational pull at the star's core during the explosion causes time to slow down, as predicted by Einstein's theory of general relativity. Especially around the black hole formed behind a hypernova, time flows much more slowly for distant observers. This is one of the rare cosmic examples showing that time is not absolute in the universe. It can change under intense energy and gravity. This bending of time is fascinating both from an astrophysical and philosophical perspective, because a hypernova provides a vivid proof that not everything in the universe is fixed and unchanging. The time perceived by an observer watching a hypernova explosion from the outside is completely different from that perceived by an observer located near the center of the event. This also demonstrates how cosmic-scale events challenge human intuitive understanding of time. Additionally, the gravitational waves that emerge after a hypernova reveal how time and space in the universe are dynamically structured. By studying how the light curves and waves emitted during a hypernova change over time, scientists can measure the age and expansion of the universe with greater precision. Thus, hypernova explosions provide entirely new insights into the timeline of the universe. In conclusion, a hypernova explosion is not merely a massive energy event, but also a unique demonstration of the relative nature of time. One of the universe's greatest mysteries lies in how time and space can bend and warp in the face of colossal events like hypernovae. Each explosion creates a new turning point in the cosmic flow of time. 47. Hypernovae and the first traces detected in space. Discovering the first traces of massive explosions, such as hypernova in the universe, is a groundbreaking development in humanity's understanding of the cosmic past. With the advancement of telescope technology, scientists are able to observe the light from hypernova explosions that occurred in the early universe billions of years ago. This light is a record of the past because during the time it took to reach us, the universe has continuously expanded and changed. Each hypernova opens a window into the universe's great time machine. The first traces of hypernova also signal the first leaps in the chemical evolution of galaxies. These first explosions symbolize the emergence of heavy elements and the beginning of chemical diversity in the universe. Scientists identify specific element signatures in the light spectra from the most distant galaxies, enabling them to determine that these elements originated from a hypernova explosion. Thus, even in the earliest stages of the universe, hypernova were the key to cosmic evolution. The detection of the first traces of hypernova is invaluable in determining the age and evolution of the universe. This is because the frequency and chemical effects of these explosions provide solid evidence about how galaxies and star clusters formed. The most distant and oldest observed hypernova traces shed light on the chemical journey of the universe dating back 13 billion years. Ultimately, the first traces of hypernovae shed light on the early universe and the beginning of cosmic history. Each new discovery provides new answers to questions about how the universe diversified and became complex. Hypernovae are not only key cosmic players in our present, but also in our past. 48. Hypernovae and humanity's place in the universe. Massive cosmic events like hypernovae are both a challenge and a source of inspiration for humanity's understanding of its place in the universe. These massive explosions, which occur with the death of a star, form the basis of chemical richness and life in the universe. Thus, all living beings, including humans, are actually the product of the cosmic legacy of hypernova explosions that occurred in the past. The phrase, "we are all made of stardust," takes on a deeper meaning in light of the hypernova reality. Understanding and observing hypernova explosions represents the pinnacle of humanity's intellectual connection with the universe. in the vastness of space, Earth, and the life it sustains, appear as a tiny drop. Yet they are an extraordinary outcome of the chemical cycles created by hypernovae. This perspective highlights humanity's fragility on a cosmic scale, while also revealing that we are an inseparable part of the universe's vast cycle. As scientists track events like hypernovae, they are re-examining ancient questions about the workings of the universe and the origins of life. Every new observation expands humanity's boundaries of knowledge and prompts us to question our place in the cosmos. From a cosmic perspective, the hypernova symbolizes both humanity's smallness and its participation in the creative cycle of the universe. In conclusion, hypernova and similar massive cosmic events serve as both a guide and a mirror for humanity's relationship with the universe. We are the living remnants of the great story that hypernova explosions have set in motion in the universe. Every new discovery contributes to our understanding of who we are and what role we play in the universe's infinite story. 49. Hypernova and dark matter theories. Hypernova explosions are also important in terms of theories about dark matter, one of the greatest mysteries of the universe. Dark matter is a mysterious substance that makes up a large part of the total mass of the universe, but cannot be directly observed and is only understood through its gravitational effects. The enormous energy released during a hypernova and the gravitational waves that emerge after the explosion provide important data on how dark matter is distributed in galaxies and how it affects the death cycle of stars. Scientists have observed that the traces of these explosions spread in different ways in regions where dark matter is dense. Dark matter can influence the movement of gas and dust clouds formed after a hypernova, the distribution of remnants left behind by the explosion, and where new stars will form are largely shaped by this invisible matter. Thanks to hypernova, it is possible to gather indirect evidence of the existence of dark matter. In particular, astronomical methods such as gravitational lensing allow us to observe how the light from hypernovae is bent by dark matter, enabling us to map dark matter in the universe in greater detail. The shock waves from hypernovae can also trigger the movement of galactic gas clouds interacting with dark matter. According to some theories, dark matter plays a decisive role in the distribution of new star clusters and black holes formed after hypernovae. Thus, hypernova explosions contribute to the understanding of not only the visible universe, but also the dark universe. In conclusion, the relationship between hypernovae and dark matter is an exciting area of research for understanding the deep structure of the universe. Each new hypernova observation paints a clearer picture of the role of dark matter in the universe and brings us one step closer to unlocking the secrets of the invisible universe. 50. Hypernovae and the fate of the universe. Massive cosmic events such as hypernovae play a key role in answering big questions about the long-term fate of the universe. Hypernova explosions affect not only the internal structure and chemical evolution of galaxies, but also the expansion rate of the universe, energy distribution, and the formation of large-scale cosmic structures. Thanks to hypernova, the distribution of elements in galaxies, star formation rates, and the evolution speed of black holes can be determined. All these processes are closely related to how the universe will ultimately end. One of the leading theories about the fate of the universe is the idea that energy and matter will disperse over time, leading the universe to a heat death. Hypernova explosions periodically provide large energy waves and chemical renewals in this cosmic journey, extending the universe's vitality and dynamic structure. However, eventually, when stars are depleted and black holes dominate, even hypernova-like massive explosions come to an end. At this stage, it is predicted that the universe will enter a dark and motionless era. Some alternative theories suggest that hypernova explosions could even lead to the formation of new universes. According to certain models, the black hole formed after a hypernova could serve as the starting point for another universe. This implies that the cosmic cycle is an endless structure that continuously opens doors to new stories. The fate of the universe may enter an endless cycle of transformation and renewal through the chain reaction of events such as hypernovae. In conclusion, hypernova explosions are not just supporting actors in questions about the fate of the universe, but are among the main characters in the big picture. Each explosion brings new answers and new mysteries about the future, structure, and infinity of the universe. 51. Hypernovae and cosmic consciousness, human perception. Hypernova explosions are unique events that make humans question their place in the universe, both physically and philosophically. The transformation of a star's death into such immense creative power and chemical diversity is a cosmic lesson for humanity. Each hypernova demonstrates how small yet meaningful humanity is in the face of the universe. This is because these colossal events reveal the raw material of life on Earth and even human consciousness. The concept of cosmic consciousness refers to the increase in humanity's awareness and intellectual depth regarding the universe as a result of major events such as hypernovas. When astronomers observe a hypernova explosion through telescopes, they are actually tracing the traces of an event that occurred billions of years ago right now. This is an experience that transcends the perception of time and space, opening the human mind to the infinity of the universe. Every observation serves as an opportunity for consciousness to open a new window on the universe. Hypernovae and similar events also generate new ideas about humanity's cosmic position in the fields of art, philosophy, and religion. The phrase, "we are all stardust," summarizes not only a scientific fact, but also humanity's existential connection to the universe. Each explosion reminds humans of both their own smallness and their indispensable role in this great cosmic cycle. In conclusion, hypernovae symbolize the continuous evolution of human perception and cosmic consciousness in the universe. Each new discovery adds depth and meaning to humanity's connection with the universe, making us both children of the stars and imaginative observers of the universe. 50. Hypernovas and the fate of the universe. The fate of the universe has been one of the greatest questions throughout human history. Hypernova explosions are one of the most important actors behind the scenes of this great cosmic game. Because hypernova are not only the end of stars, but also extraordinary energy releases that shape the evolution of galaxies and even the entire universe. The energy and heavy elements released by a hypernova determine the chemical composition of galaxies and star formation rates, while also causing black holes to grow rapidly and altering the flow of matter between galaxies. In the long term, the contribution of hypernova explosions to the overall balance of the universe is twofold. On the one hand, they provide cosmic fertility that enables the birth of new stars and planets. On the other hand, they can fundamentally alter the future dynamics of galaxies by accelerating the growth of massive black holes at their centers. In leading theories about the fate of the universe, the role of hypernovae is akin to a domino effect. Large explosions throw matter and energy into the intergalactic void, and the remaining black holes create a massive hunger in the core of the galaxy, growing by devouring everything around them. According to the theory of the heat death of the universe, heat death theory, over time, stars run out of fuel, supernova and hypernova explosions decrease, energy levels between galaxies drop to a minimum, and eventually, a cosmos-wide cold and motionless universe emerges. Hypernova explosions act as intermediate revitalizers that delay this process and produce fresh energy, matter, and elements in the universe. However, this cycle does not continue indefinitely. Just as every star, galaxy, and element has a lifespan, so too do hypernovae. Ultimately, all remaining matter transforms into black holes or dark matter, and the universe is engulfed in a great silence. However, there are also different and more ambitious theories about the fate of the universe. Some scientists believe that the supermassive black holes formed after hypernovae could create such a warp in the fabric of spacetime that a new universe could emerge from this warp. In other words, the fate of the universe could be to begin anew with another Big Bang at the end of a chain of hypernovae. Hypernova is one of the fundamental links in cosmic cycles and universal infinity. Each explosion is a gateway that melts the death and life of the universe, its end and its beginning, into one pot. Ultimately, without hypernova, the universe would not have reached its current richness, nor would the great cosmic story opening up to infinity be complete. 51. Hypernova and cosmic consciousness to human perception. A hypernova is not just the death cry of a giant star. It is also a cosmic mirror that gives a whole new dimension to humanity's questioning of its place in the universe, and the questions, who are we and why are we here? In the infinite darkness of the universe, as a single explosion echoes for billions of years. The fact that this echo reaches us is both dizzying and inspiring for the human mind. When astronomers see the light of a hypernova through their telescopes, they are actually looking into time itself, examining the traces of an event that took place billions of years ago and has been carried forward to the present. This reality overturns humanity's perception of time and space, creating an awareness that transcends ordinary life. While a hypernova explosion reveals humanity's cosmic insignificance, it also reminds us of our deepest connection to the universe. Every atom, every living being, and every consciousness on Earth is a product of the chemical legacy of countless hypernovas that occurred in the past. The phrase, "we are all made of stardust," is not a philosophical metaphor, but a direct scientific fact. Elements that once formed at the center of another star were scattered into space by a hypernova explosion, gathered in new planets, and eventually transformed into thoughts, emotions, and consciousness in the human brain. This is the universe observing itself in an immense cycle. Cosmic consciousness begins here. Hypernovas have also inspired great leaps forward and intellectual breakthroughs in human history. Understanding the vastness of the cosmos and seeing that new life can emerge in the universe from the death of a star has inspired artists, poets, philosophers, and scientists to dream endlessly. In the modern age, the observation of hypernova explosions is a testament to humanity's endless desire for knowledge, discovery, and meaning. With each new telescope and each new observation, the mysteries of the universe are unveiled a little more, while the human mind expands the boundaries of its own potential. Ultimately, a hypernova is not merely a physical event, but one of the fundamental motifs of humanity's existence. Science and art, philosophy and consciousness gain new meanings through the reality of hypernovas. In the boundless darkness of the universe, the journey of light that begins with the death of a star ultimately transforms into a new light in the human eye and human consciousness. Hypernovas are like an awakening bell that leaves endless echoes in cosmic consciousness. They are an eternal cosmic fire that reminds humans of both their smallness and their place in the creative cycle of the universe. The hypernova that emerges when a star dies in the depths of the universe is actually a symbol of new beginnings beyond destruction, of an endless cycle. These massive explosions create the greatest ruptures in the cosmic chain, transforming the chemistry of the universe, the evolution of galaxies, and life itself. Every hypernova launches hope into the intergalactic void, order into chaos, and new beings into the heart of nothingness. Perhaps humanity's greatest discovery was understanding that from the death of a star, the purest and most indispensable energy of life is born. The hypernova is both the unforgettable tragedy of the universe and the brightest harbinger of rebirth. Confronting the power that devours the universe is, in essence, touching the deepest secret of existence. Every end is the beginning of a new story in the universe. If you enjoyed this mysterious journey, don't forget to like the video, leave a comment, and subscribe to the Liminal Science channel. Your support helps us bring the deep silence of the universe, the magic of the planets, and the boundless imagination of science to more people. Remember, the universe is not just made of stars. It is also made of the lights within the darkness, the silent whispers of space, and the questions of the curious mind. The path to truth sometimes begins not with the brilliance of a supernova, but with the whisper of a thought. So, stay with us and continue to explore the unknown together.